Okay, hello everyone. My name is Ramon. I'm presenting some aspects that I've been doing here in Spain, but also in California. You all know quite well that we are in a biodiversity crisis, and currently 1/4 of the world mammal species, usually large body animals, are considered globally threatened or extinct. And in this current biodiversity crisis, translocations and particularly reintroduction of threatened species are becoming increasingly frequent, even with the species that have not existed for millions of years. However, these reintroductions are often more linked to political and socioeconomic conditions than to scientific knowledge. So there is a lack of knowledge about this. And in fact, most reintroduction projects so far have been simple management manipulations with a single species perspective. And this is the target animal species that we're focusing on. And if you look at the literature, most of the literature about reintroductions is based on population biology, genetics, veterinary management, captive management of the target animal species. We're all fascinated by large animals, and particularly by herbivores. And most of the herbivores, most important herbivores, are ungulates. And many wild ungulates are charismatic and flagship species that are continuously used to stimulate conservation awareness. There are many recent introductions. For instance, the Iberian ibex in the Pyrenees a couple of years ago, the bighorn in Yosemite also a couple of years ago, the Barbary sheep, which is not a native species in California, has been introduced a few years ago too, or big, large herbivores like the bison or even horses in Spain, in northern Spain during this period, 2010 and 2016. But I would like to go a little bit beyond and to somehow say, okay, look out and look beyond the target species. Because that species that we're introducing may look okay, but the ecosystem as a whole, how does it look like? What are we doing with the ecosystem as a whole? And then what I propose here is to use the ecological indicators that we need to somehow, because we need to somehow capture these complexities of ecosystems. And at the same time, to get a very good indicator, we need somehow an indicator that would be easy to monitor. So it has to capture the complexities of the ecosystem, but at the same time, it has to be something simple that we can monitor easily. The aim here is somehow to analyze the habitat features to ensure the suitability and the ecological sustainability of the reintroductions. And I would like to focus here in the reintroductions of dominant herbivores. Because when introductions include dominant herbivores, conservation of both the threatened herbivore, but also the natural vegetation, requires careful planning and management. So the tricky question that arises here is, how do we assess whether an introduction is suitable or not? And once it has been already introduced, how sustainable is it? And then two considerations. We can have in mind two main considerations. First, that we need ecological indicators beyond the target species, but also we need to preserve other organisms, and we need to maintain the ecological processes. So rewilding is a strategy that can, of course, with large herbivores, can fulfill those ecological processes and can help to establish the trophic interactions. But at the same time, we need to look at the whole system, and the other organisms. So what species and processes would be good indicators here? In the Mediterranean systems, we know that the dominant vegetation that we have here is mostly by woody plants. As in the opening lecture, William Bott stated, most of the Mediterranean systems are shrubland or dominated by shrubs or evergreen trees and so on. So why don't we use these woody plants? Because woody plants, we know that they are highly sensitive to herbivory and to browsing. And second, because somehow the population, the density population of the animals will be limited by the conservation of these woody plants. So what did I do? I selected a few variables here. And we studied the damage that the herbivores costs on the woody plants, the preferences, but also the plant regeneration. And we compare threatened species that are rare species in the area with common widespread species to look if there are differences between them. We predicted that damages on the threatened woody plants will be similar to those found in common taxa. This will help us develop science-based indicator of sustainable introduction and sustainable populations. So we went to areas that large herbivores were introduced during the 70s and 80s, so 20, 30, 40 years ago, and compare the effects common and rare taxa and common taxa after 25 and 40 years. We went to areas where the Iberian ibex and the Barbary sheep were introduced in Mediterranean shrublands and ecosystems. So these are the variables we measured. First, we look at the plant preferences by ungulates. So how do we do that? We used a forage ratio, which is just a relationship between the plant consumption and the plant availability with regard to the neighbors. Then we also look at the effects of browsing on woody plant composition. So we used areas where there was a fence, and on one side of the fence there were deer for the last 30, 40 years. On the other side of the fence there were no deer for the last 30, 40 years. Then we also look at the plant regeneration by measuring or estimating the probability of successful regeneration of these plant species. And we also try to estimate the relative density of the animal by counting pellet groups. The results show here that the threatened species were much more preferred than the widespread species. Remember I said that our prediction was to be similar, but we found that they were much more preferred. In fact, the percentage of plants with unsustainable herbivory levels was much higher for the threatened rare species than for the widespread plant species. We compare the percentage of unsustainable herbivory. So unsustainable herbivory means when the plant cannot reproduce successfully, looking at the reproduction success. And of course, indeed, ungulates prefer some woody species over others. And we found a pattern here where the plants that belong to the latest stages of plant succession here were much more preferred than the plants that belong to the early stages of plant succession. These are pioneer shrubs, colonizers, mostly found in the Labiatae or Cistae families. So for instance, I'm talking about lavandula, thymus, rosmarinus, and so on, plants with a lot of secondary metabolites and aromatic compounds. And this is the ecological succession, the plant succession here. After this comes some other bigger shrubs here. This is in the Mediterranean, central Spain. And then after that, there are some trees and some arbutus, filaria, and other plants that are coming until you get somehow a kind of a forest. So we found that the species that were on this part, number 1 and number 2, the late stages, they were much more preferred than these ones, mostly because of the aromatic compounds. But after 40 years of deer browsing on this area, we found that there was a big reduction in woody plant diversity. 30% of the woody plants after 40 years at high density of deer, talking about 40, 50 individuals per square kilometer. There was first a loss of diversity in woody plants, but at the same time, because that diversity was not equal, there were some species that were favored in somehow. The early stage species, the pioneer species, were replacing the ones that were in the later stages of the ecological succession. So what happened here is not only a diversity loss, but also we're threatening the vegetation dynamics. We're forcing them to return to early succession stages. So what Miguel called arrested succession, this is not only arrested succession, this is going back in the plant succession. And then we're getting degraded ecosystems because of at this high density of deer. And at the same time, what we're getting is biotic homogenization because of the loss of plant species. In this heat map, what you see here is the species, the abundance of plant species, and when deer were present and when deer were absent, you see that here we're missing quite a lot of species, and the abundance was also lower. So this is what we're doing right now also in California, a similar approach, where we have a highly preferred plant species, medium preference and low preference, according to that preference index I told you about, the forest ratio. And here you see that some species are very highly unpalatable, so they don't really like them. These, we're trying to use them to somehow, as nurse shrubs, to promote tree regeneration in the oak savannas in California. And these are species that are also highly preferred and also usually belong to the latest stages of the plant succession. So here is what species then can we use as key indicators? And then what we propose here is to use, following the definition of a good ecological indicator, is to use species that are widely distributed, easy to find in the field, and easy to monitor, and at the same time species that are highly sensitive to ungulate pressure. This means highly preferred by ungulates, so that we realize that we are somehow obtaining unsustainable populations. And those could work as suitable indicators of unsustainability. At the same time, using these species can really provide early warning of food shortage and subsequent poor body conditions of the animals. So many times when we found these sarcoptic mange or diseases in the animals, it's something that we could have seen much earlier just by looking at the vegetation. So the vegetation degradation is an early warning of this food shortage, and it's telling you that animals will get poor body conditions, and these are predisposing factors for many ungulate diseases. But yeah, this is very nice using these somehow common species that are highly sensitive, but then is it too late maybe for the rare threatened species? Maybe we have already lost some of the species. And then the effects of large herbivores on common taxa, they should be very taken with caution, because they could be very low or negligible, but they may mask unsustainable densities for the rare taxa. So maybe we're losing already rare taxa. So we should maybe look also at the threatened taxa, but this is, as you can imagine, more costly, because we have to look and find the rare taxa, and it's much more challenging. But at the same time, looking at the threatened taxa is going to give us a much more realistic and reliable indicator of the vegetation conservation, the conservation status of the community. Here is an example of a priority conservation ranking that we established using the threatened plant species. So when we look at the threatened plant species, we found that some, based on the browsing intensity and based on the natural regeneration, we could establish this priority ranking, as you can see here. And then it means that looking at the threatened species, we can also help to preserve the vegetation conservation here. This is the last figure I'm going to show is from the Iberian ibex populations, overpopulation in the central Spain. And this is what I try to show here is the probability of successful regeneration as a function of the relative ungulate density. So as you can see, when populations are low, the probability of regeneration is relatively high, and then it decreases. So what I show here is how, if we reduce this population by 50%, we're increasing more than 50%, 60%, the probability of regeneration. So, and these kind of approaches can give you an idea of how unsustainable or sustainable are the populations. So to conclude, I would like to say that the use of woody taxa through ecological indicators represents a useful tool to assess ecological sustainability of introductions. That monitor or threatened taxa might be more challenging and costly, but it seems to provide reliable and realistic indicators. That the monitoring of threatened taxa will also help establish a priority conservation ranking from plant species. And I would like to emphasize this point. This highlights the need of considering population control planning, because it's very easy to release herbivores, very difficult to control them. So, yeah, we don't have predators in many of the areas. They went extinct. And right now, for instance, this introduction in central Spain has become with the highest population density ever recorded, and it's in a protected area where hunting is forbidden. There are many people there doing recreational activities, and there are no predators, and it's becoming a problem that is degrading the ecosystem. So releasing an animal species like this without considering population control planning is not rewilding, it's just trying to reverse, and it goes against the conservation of the Mediterranean system. So, and regeneration success, finally, in threatened taxa can help estimate the sustainable animal density. So it's a good, we always wonder what is a sustainable density. We could look at the regeneration success of woody plants in the Mediterranean system, and it can help us estimate the sustainable populations. And with that, I would like to thank all these amazing people who helped me with this and the financial support of the Marie Curie Actions.